Welcome to part 2 of your 6.5 and 6.6 lesson. This video is over 6.6 and we're going to solve radical equations. So that's the whole objective for today. Alright, to solve a radical equation you need to follow these steps. Isolate the radical on one side of the equation if necessary. It may already be isolated. If not, isolate it. And then raise each side of the equation to the same power to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. Solve the polynomial equation using techniques you learned in previous chapters. Make sure you check your solution. This isn't just to make sure you did your work correctly. Sometimes you'll get what are apparent solutions, but they're not solutions to the original equation. They're solutions to a secondary equation you created along the way. All right, we've got cube root of 2x plus 7 equals 30. While our radical is isolated, our cube root's by itself. So to undo cube rooting, you cube both sides. You do the inverse operation. So we're going to cube both sides. Cube and cube root cancel. And so you end up with 2x plus 7. And then on the other side we have 3 cubed. That's 27. And so now we just solve from here. So we subtract 7 from both sides to get 2x equals 20. So x equals 10. Okay, so we plug in 10 into the original equation, make sure it works. So we have cube root of 2 times 10 plus 7. So 20 plus 7 is 27. We have cube root of 27 equals 3. Well, that means our solution checks. Let's look at example 2. What are the solutions of the equation 4 times x to the 2/3 equals 36? Okay, x to the 2/3 is the same thing as the cube root of x squared. So we want to isolate the x to the 2/3. So we're going to divide both sides by 4. And we're going to have x to the 2/3 equals 9. All right, now anytime you have a rational exponent like that, what you want to do is you want to raise both sides to the reciprocal of that value. So we're going to raise each side to the power of 3/2. Now, doing 3/2, raising anything to the power of anything with a half, that's the same thing as taking the square root. So on the number side, you need to remember to do plus or minus just like you do when you're taking the square root. Now x to the 2/3 to the 3/2, we multiply those exponents together. 2/3 times 3/2 is just 1. X to the first is just x. And then 9 to the 3/2 power, okay, that means take the square root of 9, which is 3, and then raise it to the 3rd power, which is 27. So we get x equals plus or minus 27, which means D is our answer. Now if this was not multiple choice, we would want to plug in both 27 and negative 27 and make sure that we get solutions. All right, we want to solve x plus 1 equals the square root of 7x plus 15. Well, our radical is isolated. The square root's by itself, so we're going to square both sides. It is a square root, so squaring will undo square root. So on the left, we have x plus 1 quantity squared equals the square root of 7x plus 15, the whole thing squared. Well, on the left, we're going to have to expand x plus 1. In other words, we're going to have to FOIL x plus 1 times x plus 1. On the right, the square and square root are going to cancel. X plus 1 times x plus 1 is x squared plus 2x plus 1. If you need to, pause the video, FOIL it out, and double check. And then on the right-hand side, square and square root cancel, so we just have 7x plus 15. So now we want to write this in standard form. In other words, we want to get everything on one side of the equation equal to 0 since it is a quadratic. So when we subtract the 7x and the 15 over, we get x squared minus 5x minus 14 equals 0. So now we need to factor and solve. X squared minus 5x minus 14 factors to be x minus 7 times x plus 2. We set each factor equal to 0 using the zero product property, and so we get x equals 7 or x equals negative 2. Now at this point, these are candidates for solutions for the original equation. They are solutions to our quadratic, but we need to double check that they're both solutions to our original equation. It could be that both work, none work, or just one works. All right, so we're going to check x equals 7 in the original equation, and we're going to check x equals -2 in the original equation. So when we plug in 7, we're going to check to make sure that 7 plus 1 equals the square root of the sum 7 times 7 plus 15. 7 times 7 is 49 plus 15 is 64. So we get 8 equals square root of 64, so we get 8 equals 8. So yay, x equals 7 works. So we have at least one solution. Let's try -2. So we plug that in for x in our original equation. And it's very important you go back to the original. Okay, you have to go back to the very original one. So -2 plus 1 equals square root of 7 times -2 plus 14. So let's see, -2 plus 1 is -1. And our radicands will have -14 plus 15, which is 1. Does -1 equal square root of 1? No, because remember, we're just simplifying here. And when you are just simplifying and you have the square root of 1, you just want the principal square root. So square root of 1 simplifies to be 1. -1 does not equal 1. So we have only one solution, 7. The apparent solution, -2, is extraneous. It doesn't work. All right. One more example. This time we've got two radicals. We're going to solve square root of x plus 2 plus 1 equals the square root of 3 minus x. Now one of our radicals is isolated, the square root of 3 minus x. So we're going to go ahead and square both sides to get rid of that square root sign. We're not going to get rid of both square root signs because we don't just have a square root on the left-hand side, we also have the plus 1. So we're still going to have square roots when this step is said and done on the left, but we'll get rid of this square root on the right. So we have the whole quantity, square root of x plus 2, and then plus 1 squared equals the square root of 3 minus x, that squared. Okay, on the left, we can't just cancel the square with the square root because of this plus 1. It's not underneath the square root sign. So that means we're going to have to expand that out. We're going to have to FOIL it. Okay, we're going to expand the left side and simplify the right side. So we're going to have square root of x times square root of x, which just, square root of x plus 2 times square root of x plus 2, which is going to give us x plus 2. And then when we multiply the outsides and insides when we're FOILing, we're going to get 2 times the square root of x plus 2. And then 1 times 1 when we do the last is going to give us 1. If you need to, pause the video and FOIL that out and you'll see this is what you end up with. On the right hand side, all we have is the square root inside the parentheses and then the squared outside. We're not adding or subtracting anything to it. So on the outside of the square root sign, so the square and square root cancel and leave us with 3 minus x, which is good. We wanted something to be simpler. So let's see. X plus 2 plus 1 gives us x plus 3, and then plus our 2 times square root of x plus 2. That equals 3 minus x. Okay, so we want to subtract the 3 over, so that's going to zero out, and we're going to subtract this x over to the other side. And that's going to give us 2 times the square root of x plus 2 equals -2x. Again, because the 3 zeroed out, and then when I subtracted this x over, -x plus another -x, it gives us -2x. We almost had this radical expression isolated, the square root of x plus 2. We just need to divide both sides by 2. So we get square root of x plus 2 equals -x. So now we're ready to get rid of this square root sign. We're going to do that by squaring both sides. Now, this time, everything on the left-hand side is underneath the square root sign. So square and square root is going to cancel. And so we have x plus 2. On the right-hand side, -x times -x is just positive x squared. So now we just want to put it in standard form. That means move everything over to the side with the x squared and have 0 on the other side. So 0 equals x squared minus x minus 2. So now we factor. And we get 0 equals x minus 2 times x plus 1. We use our zero product property to get solutions or potential solutions. X minus 2 equals 0 or x plus 1 equals 0. So we're going to solve for x. That gives us x equals 2, x equals -1. We're going to check these in the original equation. So everywhere we see x, we're going to plug in 2. So we get square root of 2 plus 2 plus 1 equals square root of 3 minus 2. 2 plus 2 is 4, so square root of 4 plus 1 equals 3 minus 2 is 1, so square root of 1. So that's going to give me 2 plus 1, which is 3, equals 1, which is not a true statement, so 2 is not a solution. Let's try negative 1. It could be that we have no solution, or it could be that negative 1 works, even though 2 did not. So let's plug in negative 1. So we've got the square root of negative 1 plus 2, and then we're going to add 1. And we're going to see if that equals the square root of 3 minus negative 1. Okay, negative 1 plus 2 gives us 1, so we have square root of 1 plus 1. 3 minus negative 1 is the same thing as 3 plus 1, so that gives us square root of 4. Square root of 1 is 1. Add another 1 to it, you get 2. Square root of 4 is 2. So the solution x equals negative 1 does work. The apparent solution 2 is extraneous. So we got to kick it out. Okay, so that's it. Make sure you do the problems to try on your own. There's one from 6.5 and then the rest are from this lesson. And then we will go over those at the beginning of class and get you ready to do your rounds. Have a good day.